Hello students, how are you today? I do have for you today a lecture on solutions, heterogeneous mixtures. I'm going to give you as a definition, and plus I'm going to give you examples. What is a heterogeneous mixture? It's a mixture that contains two or more separate phases. The composition is not uniform throughout. Heterogeneous is an uneven texture. For example, here I have 2 layers of water and oil. They don't mix together. Here I do have another example of iron fillings with potassium chromate. The mixture on the water glass consists of potassium, here dichromate, as orange crystals, and iron fillings. Are they mixed so well together as one phase? No. If I just put a magnet, it separates the iron fillings from the mixture. It means here I do have different phases or uneven texture. Whereas if I have a homogeneous mixture, in such a way, whenever I dissolve sodium chloride in water or sugar in water, it will be almost as a one solution, a homogeneous solution. Therefore, a homogeneous solution or a mixture is made up of 2 or more substances having uniform properties and composition throughout the mixture. They are often referred as solutions. Why? Because it's homogenized or homogeneous. Example, sodium chloride solution, sugar dissolved in water, like I told you. Here I do have so many examples of homogeneous mixture. For example, milk, the one that we drink, it's a homogeneous one. Here already I'm dissolving water in sugar, dissolving sugar of course in water, and sodium chloride in water. But for example, if I have sand and water, they are different phases, but therefore they are heterogeneous. Whenever the salt, it's not dissolved in water, it is also heterogeneous mixture. Examples of solutions or homogeneous solutions like salt water. This is a common example of a solution where salt is dissolved in water. In this case, water is solvent and the salt is the solute. You should understand this one. Solution as a whole. Solvent is water. Solute, it is the sodium chloride. It is the salt. You should understand the term solvent, solute, solution. When you dissolve sugar in water, you create a solution. Again, water acts as the solvent and sugar is the solute. I'm still talking about homogeneous mixtures. Solutions can therefore contain a solute, usually in smaller quantity, and uniformly dissolved in another substance called the solvent, which is in greater quantity. Solutes, they are not visible and can be separated by evaporation and may give color to the solution. For example, whenever you have a salt water like seawater, if I want to evaporate the water, I may evaporate it. I will get at the end the salt itself, the sodium chloride itself at the end, whenever I evaporate the water. The solute and solvents in solutions can be solids, liquids, gases. How it could be? Whenever I have, for example, I have 14 carats gold. What does it mean? It has other than gold in it, in which it is in a one form or one phase as a 14 carats, but it has brass in it, it has copper in it, but it is not only gold. Therefore, this is a solid solution. 14 carats gold, 18 carats gold, 22 carats gold. Liquids, example, seawater, milk, whatever. Gases, air. Air is a solution. It has many gases in it. Air is a mixture of different gases like nitrogen. It's almost 78% of it nitrogen. oxygen 21%, argon 1%, carbon dioxide almost 0.03%, and water vapor. And therefore air is a mixture of gases, primarily nitrogen, it's the most component, and oxygen, with traces of other gases like carbon dioxide and argon. In this case, nitrogen and oxygen, these are the major components, and the entire mixture is suspended in nitrogen. As I told you before, a solid phase, we call it as a metal alloy, like example, the brass, it's a copper and zinc, and the 14 carats gold, which is a combination of gold, silver, copper, and zinc. Similarly, also steel is a solid solution of iron with copper and sometimes other elements. What about the solvent, which is water considered to be the universal solvent, H2O? Water is highly polar, which allows water molecules to be held together more tightly, making it high density solution. Because of this, the ships, they float on the water. It has a surface tension on water. Water molecules have a slight positive charge on one end, the hydrogen side, and a slight negative charge on the other end, which is the oxygen side. Water, as I told you before, it's a polar solvent, and it is a polar solvent in which it dissolves whatever compounds that they are polar. Why? Because there is a concept that it says like dissolves like. Here, for example, I have water in which it is polar and it is positively charged as an H plus from this end. It attracts the other polar compound, which is the ammonia, and by this they will dissolve so well. This polarity allows water to attract and dissolve substances with charged or polar molecules. This, you should put it in your mind, like dissolves like, polar compounds dissolve polar compounds. And water is a polar component or solvent. Water also dissolves ionic compounds and molecular compounds that have oxygen. Example, the alcohols, ROH, or the nitrogen, example, the ammonia. As already I had shown you how it attracts the nitrogen, and it will be almost, they dissolve so well in each other because polar dissolves polar. Hence, water can dissolve salts, sugars, acids, bases, and many other substances, make it a vital solvent in various chemical reactions and biological processes. Here already I have water. It is attracted to alcohol, to the oxygen. Oxygen is negatively charged. It attracts the hydrogen, positively charged end of water, and it will be soluble in it. Water expands when it freezes, and its density becomes lower. Because of this, you see that the ice floats on the surface of frozen oceans, keeping the ocean as liquid. The ocean underneath, it is liquid, whereas you see that there are ice cubes or ice floats on the surface of the frozen oceans, but down in, it's still liquid. About 75% of Earth's surface is covered with water and only 2% is frozen. This is statistic. When water freezes, the molecules arrange themselves into hexagonal lattice due to its hydrogen bonding. As you can see the structure here, the hexagonal structure takes up more space, causing the water to expand as it freezes. Because of this, whenever you put the water bottle inside the freezer, and the water will expand. Because of this, maybe the water bottle, it will break inside the freezer if it doesn't have space for this expansion. As for density implications here, because the molecules are more spread out, it takes more space, as I told you, because it expands in the solid state than in the liquid state. Therefore, ice is less dense than liquid water. Therefore, whenever it expands, it means that it will be less dense than liquid water. Due to its lower density, ice floats on water. And this is why icebergs float in the ocean and ice cubes float in a glass of water. And this, it will provide a protection for the aquatic life. As an environmental impact, the floating ice insulates the water below, providing a stable environment for aquatic life in cold climates. And because of this, the fish, they will stay alive down underneath in water in which it is still liquid, whereas I do have ice cubes up on the upper part of water or the sea. I'm still talking about water as a universal solvent, but here these are facts as common knowledge I'm going to tell you about. About 70% of a human body is water. Water do not mix with non-polar substances such as wax and oil. It will form as two phases. Oil spills is a serious threat to the aquatic environments and sea animals. These concepts, some of the points, they are far away from each other, but we should go back to and we should know them. It is estimated that 80% of all illness in the world is caused by water contamination. But therefore, we should take this one into consideration, that water, it will be contaminated so easily. Groundwater sources in many countries are contaminated, and it is so difficult to clean up. But therefore, and it's so expensive also in order to clean it up. Because from the side, therefore, we have to take into consideration and be careful not to contaminate our water. Water is essential to our quality of life. We must maintain the quality of our water sources. Thank you so much for listening to me, and I hope that you will be with me in other lectures. Thank you.